TTL Computer 2. Today we're going to have an update on some of my software work for TTL Computer, and we'll take a look at some things in the monitor. And then in the second half of the video, I'll talk about that in a little bit more detail, and we'll look at some of the source code. So if the source code port is not of interest to you, you can drop off. Okay, so let's get going. So TTL Computer 2 is up and running right now. Terminal is going. I'm going to hit reset. And there's our welcome screen for TTL Computer 2. And then I'll just do question mark. We'll take a look at our commands here. So we can see that we have a couple of new commands here. We have copy and fill. And let's do that. We'll do fill, and our destination address is going to be 9,000 hex. And we want to fill that with, let's say, AA. And we want to do that for um, hex 100 bytes. Okay, so now we can take a look at that, dump 9,000, and then we can see there's the AAs that we added in the fill. All right, so what we can also see, that was the fill command. We can take a look at the copy command, and we're going to copy to 8,000, and we're going to copy the 9,000 that has the AAs, and we're going to do that again for hex 100 count. And now we can take a look at the 8,000, right? And we see there's the AAs that we copied from before. Okay, so those are two extra commands that we have, which are kind of convenient because when you're working on the computer and doing loads and things, uh, you frequently want to clear out some memory. And I actually do that kind of when I'm working on the stack and trying to figure out what's going on with the stack. It's convenient to do that. Okay, so let's do an Intel hex file load, and we're going to send up the file now, and we're going to just take this file, and that's going up to the computer and loading our hex load. Now, TTL Computer has been running really rock solid. I haven't had any issues at all with the computer. Running at this speed and running at the 38400 board, everything's been working really solidly and has been running really, really, really well. Okay, so that's loaded. So let's do Go 8000 to load that program. All right, so this program is kind of just in the beginning of this program is just exercising some of the utility programs that we have for doing I/O. So right now this is calling the get string uh, the get string function, which takes keyboard input. We've seen this before. 1, 2, 3. We'll see that the backspace is working now correctly. Before, remember, it was the cursor was going back, but it wasn't erasing the numbers. So here we're entering a string into the computer, and we'll just say 1. Okay. And then what it's doing is, so it's calling the get string routine. It's then converting that string to a binary number. And then we are displaying that in decimal. And then we're also displaying that in hex. So this is just exercising again some of our basic IO routines that we need, in dealing with getting input and reading string numbers in different uh, numeric bases, base 10, base 16, hex or not. Okay, so let's just do a couple more of these. We have 2. You see that that's decimal 2 and hexadecimal 2, 4, 8, 16, right? 32, 64, 128. And then, right, the maximum we can do is 255 because this is converting the decimal string into a single byte hexadecimal, 8-bit hexadecimal. So the most we can do is 255 in decimal, and that is FF. Okay, and then we can exit this little part of the program by doing 0. Okay, and that's again just showing us the zero. Now we can hit continue, and this is going to go. We're going to take a look at something else that been working on. Okay, so what we just did is we're starting to see that we have cursor control in our terminal, and you can see that we went to going to the four corners of the screen, row one, row one, column 75, row 24, column one, and row 24, column 75. And then you're seeing that we can position the cursor and we can, put text at a given point on the screen. All right, so now I'm going to hit continue and we're going to go to something else. Okay, so now what this is I've implemented code so that we can uh, initialize, so we can generate random numbers. Now we need random numbers for a lot of things in gaming, and that's really the purpose of generating that. But all right, so what the program is doing now is it's initialize the random number code with a seed number, and then we are repeatedly calling uh, get next random. And then this program is taking that random number and it's taking one random number and it's coming up with the random column. It's calling get random and then it's coming up. It's taking that 16-bit random number and making a column out of it. And then it's positioning the cursor at that position, the row and the column, the random numbers, and just putting an X. So if you're ever doing anything like creating a random number routine where you're generating pseudo random numbers, it's really good to do this, is to take the numbers and then plot them, X, Y on the screen. Because what allows you to do is really see the distribution of your random numbers and see if they're really as random as you think they are. Now, when I first started doing this and I was tweaking the random number sequence generator, but then also the code that takes that 16-bit number and makes the row and the column. Uh, it was not random. I was getting things like uh, you know uh, patterns on the screen where I was getting like, up and down patterns, and it just showed you visually that the numbers were not really uniformly distributed over the random number sequence. They were coming in clumps. Anyway, um, now this is a 16-bit random number that it's generating. So theoretically, that means that it should be able to go 65,535 random numbers before the sequence repeats. That's, a theoretical number. But I haven't yet seen the full screen get filled with X's. So I've let this run before for about 40 minutes, and the whole screen was filled up except for three points on the screen, and that's pretty good. So it was running for a whole 40 minutes, and I would see another X go on the screen. So that means the computer's been was running for 40 minutes doing generating random numbers in the sequence, and it still hadn't repeated, right? If it's still filling up X's on the screen, it means the sequence hasn't repeated. So we might get to a point where I let this run for, an hour or more, and we still might not get every X on the screen filled. And that would kind of tend to indicate that the random number sequence, did repeat and it didn't generate every single pattern of row and column that it could have. But as you can see, the screen is pretty full just through this short running, and that's pretty good. I'm pretty happy with how the distribution of the random sequence. That's pretty good. Okay, now so we're just looking at the source code from the screen program, and we can take a look get an idea for what our code for TTL Computer 2 is starting to look like. Uh, so we can see here that we're starting out and we're calling the inline print function, and that will print out this string. to the screen. And we saw that when we executed the program. Then we're going to call the getString function. And here as input, we take a pointer to the buffer, the string buffer that we want to use, and we set that for BC. Then we are pushing an immediate value of 5 onto the stack, and then we're calling getString. So that means we want to get a string up to 5 characters long. And then so that will return with the string populated. Now we're going to call um, decimal string to binary, right? And we're loading BC with the address of our buffer. Then we're calling the decimal string to binary function, which takes the string and converts that to an 8-bit binary number. Then we're going to push that onto the stack 3 times to be used later in a minute. We'll see that. Then we're going to call inline print again to say in decimal that equals this number, right? And then we're going to say call A to decimal, and that will take one of these A's on the stack, and we'll take that binary number and print that out, and we'll see that in decimal. Then we call inline print function again with the string in hex. Then we call C, we call A to hex. This time we're going to take A from the stack again, and we're going to print it in hexadecimal, which we saw. Then we're just putting out a carriage return. Then we are taking A off the stack again, which is the binary value of the string. We're comparing that if it equals 0, and if it equals 0, then we are jumping down to the screen method down here. So we saw that's a little continue message. And here's where we're starting our screen code. So here's a little macro that I put together for clear screen. Then we're calling the inline print method again. And the clear screen automatically clears the terminal window and positions the cursor at the home spot, which is going to be row 1, column 1. And so here we're putting out the 1, column 1 that we saw. And now here, so the screen function takes BC as the input, and B is the row, and C is the column. So you see we're setting that up to row 1, column 75. We're calling the screen function, and then we're printing out 1, comma 75. Then here we're saying row 24, column 1, calling the screen function to position the cursor. Then we're calling inline print to print out 24, comma 1, right? And we do that for a bunch of the rest of the values. Now, here's our random section where we're putting all the X's on the screen. And here we're loading BC with a random number seed, which is just this number here. We're calling the rand_init function. And then we start getting our random numbers. So here's get our next random number here. And then we're doing some math gyrations to make that be a column, I think. And then we're calling rand again and going through some math gyrations to set up the row. So BC now are set up at the row and the column. And so we call screen to position at that random row and column. We just put an X on the screen, and then we jump back to do it again. So that's kind of what the code is looking like in TTL Computer 2 and for the screen function. Okay, so we're back now, and this has been running for some 50 minutes or so, and we can see that this got even further than the last time I ran this, and we just have 2 spots not filled, and they're at the extremities. Row 1, column 80, and row 24, column 1 is still not populated with an X. So this could probably still run a little bit longer, and that might fill in those 2 spots. I'm not sure, but if it does fill them in, again, it would tend to indicate that the sequence has not yet repeated, even though it's been running for about 50 minutes. But that's I'm going to stop us here. And anyway, I'm satisfied with the randomness of the sequence, and the sequence is long enough for my purposes. And I'll call this a random sequence victory. Okay, so that's it for today. Until next time, thanks for watching.